So we're here for the drawing of the bending moment and shear force diagram of example 12. So we open a new Excel worksheet and um, you could just follow along as I am working here. So we'll keep the pace as the video. You could pause the video as I go along. Right? And so that's an indication of what to do in example 12. Now, this will look bigger in my Excel because I increased the font size so that those of you on the video could see it clearer what has been typed. Right, so yours will look smaller or normal. So the first thing we label a column. So we say X, brackets we put, so X is in meters because we plotting along the X or the distance along the beam. The next column we could say V, which is your shear force, and the unit, so that is in newtons. And next column is your bending moment, which call M, and the unit, so that is in Newton meter. Right, so we plotting this beam. We're going from, if we could recall, we're going from x is 0 to x is 6.2. So I'll just pull up the diagram of the beam here. Right, so I'll just pull up the diagram of the beam here. So we're going from x is 0 all the way to x is 6.2, but remember, as in the solution, we have equations at different points, a to b, b to c, and then c to d. So we start off with x is 0, right? Now remember in the introduction video, we want to take it an ascending order, because if you drag this here, you will just get 0 throughout. So we want to go in steps of 0.1 meters, right? You could go to 0.001. I mean, the more detailed you go, or the smaller the increment, the higher the detail of the graph, right? But in increments of 0.01 is good. So that means we put equal signs. We add the previous cell plus 0.1. So what that means is that every cell going down here will have an increment increasing by 0.1 meters. Right, so enter. So you go from 0 to 0.1. So as we drag this now, you could see it increases. So it increases 0.1 meters along the length of the beam. Now, if we could recall, the first region is from x is 0 to x is 2.6. Right, so what we will do, we will drag this until we see 2.6. Right, so 2.2, 2.6. Right, so what I'll do, let's shade it. So the shade, you could just left click, you drag down, right click, and you click this little paint bucket here to shade. So you could select a color to shade. Right, so as you can see, we lose the lines in between, so they get back the lines or just some resemblance of lines or some separation. We highlight again and we click over here. So this is where you have your borders. So we go to all borders, meaning that we want all the lines separating itself. Right, so now that we have the distance, now we need to put in the equation. So what I've done here is just to bring across the equation so we will see it as we type it on. So the first region was from A to B, and this was the equation we had derived in the solution. So we come to our cell and we said equal. Right, so whatever you're typing here, well, whatever you're typing the formula by is what is in the cell. Right, so we could go equal and then, right, so 134.6 x squared. So that is really multiply. So this is the asterisk on your number keyboard of your, well, on the numbered keyboard, that is the asterisk, or it will be shift, hold on shift and number 8 on your keyboard. That asterisk is what we're using there. Right, so x squared, so we know that x is what we have in the first column. So we click on that. This case is B5. And we see that it is to the power 2. So to get to the power, we hold on shift and number 6 on the keyboard. That will give you a little hat. and then we go 2. So b5, which is x to the power 2, which is squared. And then we continue, minus 1600 times x again, plus 6040. And we hit enter. Right, so when x is 0, the shear force is 6040, which makes sense here. Right, so what we could do now, we could drag this down now, just as before, and the equation now fills in. So here's when x is equal to 0.1, when x is equal to 0.2, etc. Right, so what we could do also is like, just as a check, we could confirm the final value here at 2.6 to make sure that the equation is correct. Right, so if you pull up the solution, right, so just as a check, we could see that when we was looking at between points B and C, remember we did a boundary condition at x is equal to 2.6, and we said that the shear force will be equal to the shear force of equation AB at 2.6, and that value here was 2790. So if you go back, 2790, well, almost close to 2790, right? 2789.86, right? So normally I would round off these large values because it's so big that the decimal doesn't really make a difference. Then of course Excel will give you all the decimals. Right, so the next step here now is to do now for this region between B and C. Right, so what we could do between B and C is goes up to between 2.6 and 5.2. So we could drag this here now until we see 5.2. 5.1, 5.2. Right, and then what we could do, we could change the color of this. Let's just show that it is a different region. Right? So now what we need to know is put in that shear force equation for that region here. Right, so that is this equation again from the solution. So again we could come here, we could click equal minus 900 times x plus 5130. Oops, I think something went wrong there. Let's do it over. Right, so it's made an error here, 5130. Right, so that is the shear force equation. Again, what we do after, we drag this all the way down. Right, and we could see there now that the value at 5.2 is 450, which is in tune with what we got in the yes, 450, which is what we got in the solution for the shear force at this location. Now with this screencasting, what happens sometimes if I click on another window, that video will take over the video. So that's what is what you saw just now. Right, so the next step now is to get between C and D. Right, so it goes all the way up to 6.2. So again, we click and we drag all the way down until we see 6.2. Right, and what we could do again, we could just change the color. Right, so now we're ready to enter the equation. So this is the equation here. Let's drag it down so we'll see it. So it's equal to 450 n times x squared minus 5580 times x plus 17298. Right, so we could drag this down, and you can see at the end here the shear force goes to 0, which is what we expect for the end of a cantilever beam. Right? So now that we have the shear force, now we could do the bending moments. Right, so the process is the same. So I'll speed up the video or jump to this portion where we have the bending moments to input. Right, so we have the bending moments to input. So we go for A to B again. 44.87 times x, which is your B column. And now it's to the power 3 because it's cube. So we go shift 6, which is the hat, the power 3. And B. Right, so again, I could double check this. You could see that at 0, the value is 15,450. Right, so that is so if we go back up to, so we could see our bending moment at the end was 15,450. Well, of course, will be negative, the actual bending moment. Right, so we could know that that means the Excel sheet here is working. So we could drag this down here. Right, so remember again at the end here, 2.6, this was our boundary condition for the other region, BC. So you could cross-check this value here with that value to ensure that the Excel sheet is working. Or you could just substitute by hand with your calculator and put in x is, say, example 1.9 into this equation and see if you actually get back this value. So that's one way of testing your formulas, because you will make mistakes in entering these long things. Okay, so I'll quickly jump to the end and where I've put in all these other equations. Right, so I've entered the equations. Now if you notice at the end here, we're supposed to be 0, but in fact we're seeing 0.2. Now 0.2 is very small for the values we're looking at, right? But we will try and clean it up to make sure, because we got a nice round 0. So we want to have a nice round 0 because the bending moment at the free end of our cantilever is 0. Now, in actual, when we're actually working out this value, and you could work it out on your own, and you would see that the 35,749 was rounded off. The actual value that I got in the calculator was 35,749.2. But for the sake of writing the numbers out nice and neat and having everything fit in the PDF, I took off the 0.2, rounded it off. Right, so if you include back the 0.2 here, hit enter, you would see that it will actually go back to 0. Right, so it's just a bit of rounding off error, and there's no problem if it is you have 0.2 here remain, or 0.3 or whatever. Right, you would not be penalized for that in any way, because the numbers we are dealing with are in the thousands, as you see. Right, so now we would go on now to actually drawing the diagram, or using Excel to actually draw the diagram first. Right, so what I did, I clean up here, move this over here, made it smaller. So now we're going to insert the graph or insert a figure for the shear force and bending moment. So we click the insert, then we come to our charge. Now you could recall that we did a basic plot of force versus time in the introduction. So again, we come at scatter, and we don't really need to see the points. All we need to see is the line, right? Because we saw in the books and in the notes we just join lines. So we go to our scatter without data points, or a scatter with smooth lines. So we click on that and we have the blank chart here. Right, so you click on it, and then again your alert might be a bit different depending on what version of Excel you're using, but essentially you're looking for select data. So select data, and we need to add our first graph. So what we will do, we're going to add shear force diagram and bending moment diagram in the same plot, just to make things a little compact. So click add. So the first one would be our shear force. So the x values would be the distance along the beam. So right, so what I'll do, I will just repeat that process because I did not talk it through just now. So we type in the first diagram, which is the shear force, and to get the x values are the values along the length of the beam. So we come here and we select range. So that's this up arrow here. So what this does is puts us in a mode where we need to select the cells that we want to represent the x-axis. So we click on top. So you notice the highlight is now a checkered box that is moving around. So we keep our finger on the left mouse button, and then we drag all the way down. So we highlighting all these x values from the lowest to the highest. So all the way down to 6.2. And then you hit enter. So you can see here the series x values. It shows us that is equal to, meaning that that is what the formula is, what we want it to be. Sheet 1, we are in sheet 1. And you go from B5 all the way to B67. Okay, so the next one, now we repeat the process now with the y values. The y values of the plot in this case is the shear force value. So we click the up arrow, come back up, we select and we drag all the way down, selecting all the shear force values. Then we hit enter. So with that there, we click OK. So we now have our shear force. If we were to scroll up here, well, we can't because this dialog is here. If we click OK, we would see we have the shear force diagram here. So all the way from 0 to 6.2. Right, so we can make it a little bigger. Move things around a bit. Right. So the next thing we want to put now is the bending moment diagram. So you click on your chart. Again, you go into chart design. That will be up here. It will only come up when you actually click on the chart. So you notice only when you click on the chart, then you will see it come up. Right? You go to select data again, and now we click add. So we're gonna add another legend or another series to this. So again, we call this series name bending moment. And our x values is, of course, x distance along the beam, and the y values are the value of your bending moments. So you could click OK now, and now we have our bending moment here. Right, so Unfortunately, now we have shear force values and bending moment values. So we have newtons and newton meters on the same side, which doesn't make sense. So we need to now have another y-axis on this side to represent another value. So for this, we click on the line we want represented on another y-axis. So in this case, we click the bending moment line, and we right-click it, and we will see Format Data Series. We click on that, and we want to plot this series on a secondary axis. So we click on that. So what that would do is give us another y-axis here that will only have values pertaining to the bending moment. So you have bending moment on one side, and you have shear force on the another side. So then you can click OK. Right, so we now need to add some titles and some legends to know what color is what and so forth. So again, we click on our chart design, and we want to add chart element on the upper left hand corner here. So we go to chart title. Right, so on our chart title, there's a text box here. We could change it shear force and bending moment diagram example 12. Right, we can add another element and shows the label on the y-axis. So we go to primary horizontal axis, which is the x-axis, and we change this to x along the beam, meaning at the x distance along the beam. Units are meters, so you always put your units. The next, we want to do the vertical axis, so we go to primary vertical, which is the one on the left hand side. So you see it shows up here, and we call this V. This was your shear force. The units was newtons. Then we had another here, secondary vertical, and this was the bending moment. The units were newton meter. Right? If you want to change the size of text for all these things, you could just in your chart just click on the actual text box. You go to home, and you could increase the text size. So you could increase that to 20. We could increase this to 18. 18, and then you could actually change the text of your labels on your axis. So in this case, we just select it, and we go to probably 14. Right. Now what we want to do is, we didn't change this side. Right, so the maximum bending moment or the bending moment does not go above 0. We know that. But yet it has 200. So we want to clean this up. So we click on it, we right click, we say format axis. So when you click format axis, you would see these values here, bounds. So the minimum is minus 18,000, which is okay. The maximum is 2,000. We don't really need to see anything above 0 because we know the bending moment does not go positive in this problem. So we can keep it at 0. Close that off. Next, we want to add some grid lines to this because we want to see exactly, like for example, the length of the beam is up to 6.2, but it goes up to 7. So we want to see a little more detail here. So again, format axis, and we could change that. So our minimum is 0, our maximum is 6.2, the length of the beam. Right, so it goes to 6.2. right? So you notice it automatically puts in minus 0.8. We don't want that. We wanted to start from 0, right? So you see there's a there's a battle between having 6.2 here and having minus 0.8 here. So the next thing we want to do is our minor grid lines. If you check the units on the right hand side, there's 0.2. We want to have small lines that represent that 0.2. So we could add your tick marks. Right, so you show your tick marks there. And to add grid lines, what we need to do is close that off. Chart design, we go and add elements, and then there's grid lines here. So the primary horizontal, primary vertical is what is being shown already, right? So that's your major. Your major lines are the lines that have your labels on it. So for example, if you look on the x-axis, you'll see 1, 2, 3, 4, and those where you have the lines coming up. So those are your major. So we want to get the minor, which is 0.2. So on our primary horizontal axis, that will just say minor vertical. We can click on that to get our vertical lines coming up. So at each individual will be 0.2. Right. So one last thing that is missing is what color is what? What is shear force? What is bending moment? I mean, we know because we did it. We know that the shear force comes from a positive value, or it goes all the way down to 0, and vice versa for the bending moment. But for someone who's looking at the report may not know. So we go to chart element again, and then we add a legend. So we could add one on top. So that's the legend there. We could increase the size of it, the font. So now we see our shear force and bending moment. Now what you could do is you could play around with these settings. You could play around and let's click here, format data series. You could change the line, for example, you could change the line to green, and the shear force, the legend will be updated. You could actually make it thicker. You could make it dashed. So a number of different things you could do afterwards, just to complete the diagram. Right, so both diagrams were done on one plot just for the sake of having it neat into a nice one graph. But what you could do now as an exercise, you could do it at 2 separate plots. Have your shear force as one, your bending moment as another one. So that's one thing you could do now after watching this video, so that you'll get practice in drawing plots. Right, ideally, it would be nice if this diagram could sync with the plot, such that we could see the different points. But I mean that'll be a bit difficult to try and scale that to do, because this year was hand drawn. But this diagram is good. I might indicate in the assignment where it is I want you to use Excel. Okay, for the basic examples that we did with point loads and stuff, we could do that by hand. But where we have complicated equations, for example, we have equations to the power 3 and all that, we cannot really approximate those curves. So you would need some drawing program. Okay, so again, if you have any questions, feel free, hit them up with some emails. We could use Canvas, have discussions. So see you again in another video.